Okay, welcome back all on the study of elementary logic for the first year BA LLB students, semester 1 from Mumbai University syllabus. This is the part 16. We are studying modern classification of propositions. This is also a very easy topic. Let's go through them. What is the aim of modern classification? First, let's look at the limitations of traditional classification. Traditional logic focused on categorical propositions A, E, I, O forms, which has been talked about in many of my previous videos. So if you don't understand what this is, you'll have to go and check those previous videos. They lack the tools to handle complex relationships. That is, John is taller than. There's no such thing as taller than in the traditional logic. Conditional reasoning. If it rains, the ground will be wet. There's no conditional reasoning in traditional logic. So there are all these limitations. Compound statements involving multiple propositions. So all of these three are missing in the traditional logic, which has now been incorporated in the modern logic. Next, let's look at the need for the modern classification. Modern logic introduces precision in analyzing complex arguments and deals effectively with compound and relational propositions, making it highly applicable in legal reasoning and critical thinking. What is the role in legal reasoning, that is, of the modern logic? The modern logic study helps analyze the structure of legal arguments, identifies logical inconsistencies in contracts or testimonies, and it assists in understanding implications and equivalences in legal statutes. Let's look at the kinds of proposition. First, simple proposition, where a statement either asserts a single fact only. A statement asserts a single fact is known as simple proposition. For an example, the contract is valid. Just a very simple statement asserting a fact that the contract is valid. What are its characteristics? It contains no logical operators. It can be either true or false. Let's look at the compound propositions. Propositions formed by combining two or more simple propositions using logical operators. The types of compound propositions. First, conjunction. This also we have studied. It is represented by this symbol and it means and. Conjunction combines two propositions where both must be true for the compound, that is for the conclusion, to be true. Example, the contract is signed and stands for conjunction. The payment is made. So basically it combines two propositions, proposition 1 and proposition 2. Okay, let's look at the disjunction proposition P or Q. So this stands for Q, or sorry, the symbol stands for or. This symbol stands for and. Alright, let's look at the two types of disjunction, inclusive and exclusive. In the inclusive disjunction, true if at least one proposition is true, that is the compound, that is the conclusion is true if at least one proposition is true. So if, let's say, there are two propositions, proposition A and proposition B, and then there is a conclusion out of these premises. So if any one of these is true, if the symbol used is of disjunction and any one of this is true, then the conclusion will be true. Otherwise, it will be false. So any one of the proposition, or at least one of the proposition, needs to be true for the compound or for the conclusion to be true. Now, example, the plaintiff wins or the defendant wins. Either one of these statement needs to be true. Exclusive disjunction. It is true if exactly only one proposition is true. So in this case, this is excluded. These two, that is false, false, are excluded from the exclusive disjunction. In this, exactly only one proposition has to be true. In the conditional proposition, P implies Q. This means this arrow, right-headed arrow, means implies. Excuse my handwriting. It represents implication, where the truth of P guarantees the truth of Q. If P is true, then Q will be true. Example, if the agreement is breached, true, it is breached, then damages will be awarded, true. If the agreement is breached, false. Sorry, if the agreement is breached, it's false, then damages will be awarded will also be false. Alright. So next is biconditional. That is, if and only if. It is true, that is, the conclusion is true when both propositions are either true or false. For example, there is A and there is a B proposition and there is this conclusion. So what it states is, only when both are true or both are false, then the conclusion will be true. Otherwise, it will be false. That is, if any one of these propositions A or B is true false or false true, then the conclusion will be, or the compound will be, false. This is what biconditional means. So let's take an example. The contract is valid if and only if it is signed by both parties. So the whole statement becomes true only when both the statements are either true or both the statements are false. Negation by using the symbol L, almost like an L, sleeping L. So it denies the truth of a proposition. So it says the document is not authentic. So, and another example would be, he has gone to watch a movie. He has not gone to watch a movie. So basically it denies a proposition. It goes against, basically it negates that proposition. So by stating not authentic, document is not authentic. The document is authentic, the document is not authentic. So let's say we can represent the document is authentic. The document is authentic by, say, D. So the document is not authentic will be represented by not D. This way. So this particular thing will be represented by this symbol. Alright, now let's look at this very simple basic truth table. Don't worry at all. It's a very simple table. I'll explain step by step. This is a table that I had learned when I was doing my computers, hardware networking. So at that time this table was there. This is known as the truth table. So these are two propositions, P and Q. First just look at this table, this side. Okay, now what we'll do is we'll go step by step. One here, then second here, then third, fourth and fifth. But first let's focus only on number one here, this table. So what is this symbol? I'll tell my answers after 2 seconds, so you can say that. Okay, this represents conjunction or an and symbol. So it says P and Q. Now what did we learn earlier in P and Q? When only in P and Q both needs to be true, then only the conclusion or the compound of P and Q will be true. Otherwise it will be all false. But for P or Q, this is OR symbol or disjunction. This symbol represents disjunction or symbol, OR. Alright, in OR, what it stated earlier was any one of the proposition, if it is true, then the conclusion will be true. So we see both are true, then the result will be true. If any one of them is true here, the P is true but Q is false, doesn't matter. But P is true, so the answer is true. Similarly, Q is true out of these two propositions, then also the answer will be true. But if none of them are true, the answer will be false. Now let's move to P implies Q. In the P implies Q, if and then it is. If P, then Q. So it says that when both are true, the answer is true. Both are false, the answer is still true. But if the first proposition is true and the second proposition is false, then the whole result becomes false. Did you get it? So when we do implication necessarily means that if P is true, then Q will be true. So first part we cleared. This is very clear. If P is true, then Q cannot be false. So this is false. Right? Okay. But if P is false, Q, that is what it implies, could be true. So it is true. Now, similarly, if P is false, it implies Q is also false. Fourth, biconditional. If and only if. If and only if P is true, then Q will be true. If and if only P is true and Q is false, then the entire compound will be false. That is, if P is true and Q is true, then only the compound will be true. Compound means conclusion I am talking about. Similarly, if P is true and Q is false, then the whole thing becomes false. If P is false and Q is true, then the conclusion becomes false. Now, we can learn more about this later on. I'll explain in depth. But just go through the truth table for now. Alright, we'll skip this and we'll move on to the negation part. It says then when both are true, it becomes false because we are saying this is a false part. I'll explain this in more detailed table, but as of now we just try to understand this truth table for time being. We'll go into in depth later on in the next video, or a video which will bring up this particular topic. Alright, so applications in legal reasoning. Conjunction. Where do we use it? Conjunction is used to evaluate whether all conditions in a contract are fulfilled. Correct. Disjunction determines alternate outcomes in legal cases. Correct. Conditional models cause-effect relationship in legal reasoning. So conditional logic models the cause-effect relationships in legal reasoning. If this happens, then that will be the punishment. So for example, if somebody commits a crime, he will be punished, and so on. If and then. Biconditional represents equivalence in legal terms. That is the reciprocal obligation. if and only if these particular terms are agreed upon, then the contract will be signed. So that is biconditional. Negation challenges the assertions or statements in the testimony. Alright, let's look at few of the exam focused Q&A short ones. We can expand by combining all of them for a longer answer. What is a simple proposition? It is a statement asserting single fact without any logical operators. What does a conjunction represent in logic? A compound proposition is true. A compound proposition means P and Q is a compound proposition. P or Q is a compound proposition. Now we are talking about conjunction here. So a conjunction, how is it represented? So a compound statement is true only if all constituent propositions, that is P and Q, are true. What is the truth value of P then Q when P is false and Q is true? This is an implication. If P is, what is the truth value of P when P is false? If P is false and Q is true, so this is the table that if P is false and Q is true, the whole, because in the or we had stated earlier that either one of the proposition needs to be true for the outcome to be true. So here we are going for implications. So in implications here, if P is false but Q is true, that is if it implies something, then the whole thing is true. Provide an example of biconditional proposition. Answer. A case is closed if and only if a verdict is reached. That is, a judgment is given. Multiple choice questions. A simple proposition always involves two statements, contains no logical operators, is always true, cannot be negated, contains no logical operators. Sorry, I already gave away the answers. Alright. Let's look at the second MCQ. Which truth table column represents a negation? So this is the symbol of negation. A disjunction P or Q is false when both P and Q are false. This is the truth table. Do let me know if you have not understood the truth table, and I'll expand on that in a new video. What is the truth value of P implies Q? If P then Q, when P is true and Q is false, it is false. If P is true and Q is false, so Q cannot be false. So what it's trying to say is, if P is true, then it implies that Q will be true. Then Q cannot be false. So that is why the answer is false. Alright. A simple proposition contains no logical operators. That's correct. So when we are doing all of these fill in the blanks MCQs, that also will brush up our understanding of what we have studied so far. And we can use these fill in the blanks to in our question paper. The operator and in logical represents conjunction. A biconditional proposition is true when both propositions are either true or false. So we'll have to go through the truth table to be able to give these answers. The truth table for negation P involves switching the truth value of P. Correct. I hope you have understood the truth table. Let's Look for true and false statements. A simple proposition can contain a conjunction. No, it cannot contain a conjunction because it's a simple statement. It does not have any what? It does not have any logical operators. The truth value of P or Q is true when at least one of P or Q is true. That's correct. Yes. Do try to understand these. It may sound confusing, I'm not sure. But if you have understood the truth table, then you'll be able to very easily answer these questions. A conditional statement P implies Q is false only when P is true and Q is false. Did you get this? It's very simple that, for example, if it rains, the ground, so I may just type it out for you to understand this particular sentence. If it rains, the ground will become wet. So in this, what has happened is, this is a if and so if it rains, if this is true, then this has to be true, the second part. Okay, this is what it implies. But now let's go to our question here. If the conditional statement P implies Q is false, that is, the conclusion is false, that is, they are saying is false only when P is true. So if this is true and the Q is false, it cannot become false, right? If P is true, then Q has to be true. But if Q is false, then the whole condition or the whole conclusion will be false. This is what the conclusion is trying to say. So the whole statement is correct, true. I hope I have not confused you further. Negation inverts the truth value of a proposition. Correct, true. So this completes our topic on this completes our topic on general propositions. So this completes our topic on the modern classification of propositions. That is, what is the aim of modern classification, kinds of simple and compound propositions, and the basic truth tables for compound propositions. Thank you very much. As usual, I have to say that if you have enjoyed, rather not enjoyed, but if you have listened till the end of this video, do consider sharing it with your friends. Thank you. Take care. Bye bye.